Welcome back, everyone. This video is to go over the fraction operations review for your test this week. Remember, honors, your test is on Thursday. 6th grade, your test is on Friday. Just remember to study over, look over everything, and you will do just fine. In this video, I'm going to go step through step on each problem so you can see what I'm thinking and how I solve the problems, and hopefully you can just be checking your work or making corrections if needed. Let's start by looking at Part A, where we are looking at comparing fractions. There are different ways you can compare fractions. You can use benchmarks, you can use common denominators, sometimes you can just use common sense as well. So if I'm looking at the first one, I would think about using benchmarks. 8/10 versus 3/8. Well, 8/10 is greater than a half because half would be 5/10. 3/8 is less than a half because 4/8 would actually be a half. So I know 8/10 has to be greater than 3/8. Now if I'm looking at 4/5 versus 7/15, I may also think about using benchmarks for this one because 4/5 is really close to a whole, where 7/15 is close to a half. So I could say that 4/5 is greater than 7/15. If you wanted to, you could also change 4/5 to have a common denominator of 15. So I know I would have to times by 3 over 3. So 5 times 3 gives me the 15, 4 times 3 gives me 12. So now I know for sure 4/5 is greater than 7/15. Okay, once again you could use benchmarks for number 3. 2/5 is less than half, where 13/15 is really close to 1. But we could also, once again, make a common denominator. If I want to go to 15, I would do 5 times 3. So then I do 2 times 3, which gives me 6. So I know for sure 13/15 is greater. Moving on to Part B. In this section, we are going to change mixed numbers to improper fractions and improper fractions to mixed numbers. So the first one is changing a mixed number to an improper. So if you think about your mixed number, the 3 means I have 3 wholes, which when out of 8s would mean I have 8 eighths plus 8 eighths plus 8 eighths, plus I have this 5 eighths. So one way you could see this is thinking, oh, I have 8 times 3, which gives me 24 eighths, plus the 5 eighths would give me the 29 eighths. That is one way to think about solving mixed numbers. Okay, now going from an improper to a mixed number, you need to be thinking, how many times will this 6 fit into 35? So it's like just simply dividing. It's saying 35 divided by 6. So I know 6 will go in there 5 times. So I know that 6 times 5 is 30. So I'm going to take 30 away from that 35. I would have 5 left, and it's still 6. Okay? That is one way you can solve these. So another way I saw a lot of people doing this week was just writing it as a division problem, which works just as well. I know 9 will go into 47, or 5 will go into 47 9 times, which is 45. Subtract, I have 2 left over, which means I have 9 and 2/5. Okay, and then the last one. So another way to be thinking about changing a mixed number to an improper is you are going to multiply the whole number by the denominator, because that's how many, once again, how many wholes. So here I have 4 wholes, so 4 times 7 would be 28. So I could say that whole 4 is actually 28 over 7, plus 1/7 would give me 29/7. Part C is ordering from least to greatest. On A, the first thing I would look for is, do I have any impropers, which we don't in this problem. You may also look to see if you have any that you could simplify. Well, I could simplify 6/12 to a half, and I could actually simplify 8/10 to 4/5. And my thought first is to use benchmarks. 2 9ths is really close to 1, so I look through all the other ones. 5 eighths is more than half. 4/5 is more than half. and 6/12 is exactly half. So I know 2/9 would be first. Remember, these are least to greatest. Okay, next I would look for, are there any that are less than a half? Because I know I have the 6/12, which is half. 5/8 is more than half. 8/10 is more than half, so 6/12 would have to go next. Okay, so we've taken care of those two. Now we're having to look at 5/8 versus 8/10 or 4/5. So you might want to actually make those into common denominators. So let's say we change them to 40. So I'm going to change 5/8 to be out of 40. So that would be 8 times 5, and then so I'd have to do 5 times 5, which gives me 25. And then I have the 8/10 to get to 40 times 4. So I'd have to do 8 times 4. Sorry. 8 times 4 gives me 32. So now I know for sure that 8/10 is greater than 5/8. So I would say 5/8 comes first, and then 8/10. Now we're going to use the actual number line to compare to see if you like that way better. On the test, you can use whichever way you prefer. So I think about, what does 2/2 represent? It represents a whole. So this is actually like 1. So 2/2 would actually fall where the 1 is on the number line. 4/8, I know 4 is half of 8, so it would actually be at a half. So I'm going to put 4/8 there. So we've got both of these taken care of. And then 1/6 is going to be less than a half, so I know it's going to fall in this section. I'm going to wait and come back to it. I know 1/24 is going to be really close to 0. Then I have 11/12, which is really close to 1, and 3/4 is like halfway between a half and 1. So I'm actually going to change this and make this into fourths. So now I know that this is 1/4, 2/4, so this has to be 3/4. Okay, now I have 1/6, 1/24, and 11/12. Well, I know 11/12 is really close to 1, so I'm going to put it close to 1. It does not have to be exact. 1/24 is going to be really close to 0. And then I know 1/6 is less than 1/4, but it's going to be close to 1/4, so I'm going to put it right there. Okay, so now I could actually rewrite this, ordering them from least to greatest, because they are in order on my number line. So there you go. Part D is looking at multiplying fractions. So the big thing with multiplying fractions is we multiply the numerator times the numerator and the denominator times the denominator. And it says to simplify your answers, do not leave answers as improper fractions. That's really important. Remember to read directions. So on this first one, I would multiply numerator times numerator, so 2 times 3, which gives me 6. And then 7 times 5, which gives me 35. So then I need to stop and think, can I simplify 6 and 35? So I think of, what can I multiply 6 by? 2, 3, 6. 2, 3, and 6, none of those go into 35. So this is in simplest form, 6/35. Okay, now we're going to multiply the next one. We could do 3 times 9, which would give me 27. And then 4 times 15, which gives me 60. Looking at these, I know 3 goes into both of them. So I'm going to divide the top and the bottom by 3, which would give me 9/20. And now I'm thinking, well, nothing can go into 9 and 20 that is the same, so 9/20 would be the smallest. Okay, the last one I'm actually going to bring down here to work for more space. So when you are multiplying improper or mixed numbers, we need to change them to improper fractions. So 2 and 1/7 we would actually change to 2 times 7 would be 14, plus that 1 would be 15. So I have 15/7 times 1/3. And now we can multiply straight across and get 15/21, or 15/21. And I know right away that 3 can go into both of these. So I'm going to divide them both by 3. I'm going to come down here since I'm running out of room. That would give me 5/7. And that would be in simplest form. One thing I do want to talk about real quick is if you have, for example, 6 times 2/3, you do not do 6 times 2 and 6 times 3. You have to change the 6 into a fraction. So you would have 6/1 and then multiply straight across, which would be 6 times 2 is 12, 1 times 3 is 3, 12 divided by 3 gives me 4. I know this wasn't on your paper, but I just wanted to go over that because I saw on the concept check several students were making that mistake. We are now on part E, the division part of fractions. Please know that you can fast forward through the video and look at only the questions you need to, or you can watch the entire video. I don't want you to feel that you have to watch this entire video. So last week when we were talking about dividing fractions, we discovered that you could multiply by the reciprocal of the divisor to be able to make it easier than to actually divide. So let's look at this first one. I'm going to rewrite these as multiplication problems. So I have 3/9, and we are going to multiply that by the reciprocal of 3/18, which would be 18/3. Okay, so then I have to think 18 times 3. 8 times 3 is 24, and 3 times 1 is 3, plus that 2 makes 5, so it's 54. 9 times 3 is 27. Well, remember, fractions are just division problems, so if you think of 54 divided by 27, that actually gives me a whole amount of 2. So that would be the simplest form to write that problem. Now on to 3 3/4 divided by 5/6. We have a mixed number again. Remember, since we are changing these to multiplication problems, it needs to be changed to improper. So we think about 3 times 4 makes 12, plus this 3 right on top makes 15. So I have 15/4 times the reciprocal of 5/6 makes 6/5. So remember, your reciprocal is always the divisor. It's always the divisor in every single problem. And then we can multiply straight across. So 15 times 6, you get 5 times 6 is 30. 6 times 1 is 6, plus 3 is 9. So I have 90, and then 4 times 5 is 20. So then I think this is like 90 divided by 20. 20 can go into 90 4 whole times, which makes 80. That means I would have 10/20 left over, which could simplify if I divide both of them by 10 into 4 halves. 4 1/2. Okay, and the last one, remember that when you are writing whole numbers as fractions, it's over 1. So if I had 6, it wouldn't be 6/6, it's 6/1. So, but we still have to rewrite these as multiplication problems. So I have 4/7 times the reciprocal of 6 would be 1/6. Okay, so it'd be 1/6. Then we can multiply straight across. 4 times 1 is 4, and 7 times 6 is 42. I'm actually going to put a line here, bring this down to simplify. I know 2 goes into both of these, so I'm going to divide the top by 2 and the bottom. So this would give me 2/21. So that would be in simplest form because 21 is not an even number, so I know 2 cannot go into it. We are now moving on to part F, but I noticed on the review I put part E again. Oops. Part F is going to be the word problems. So these are a mixture between multiplication and division. The best way to think about it is dividing. You are dividing things up. You are separating them into groups. So let's look at this first one. Tamara is making a large omelet and needs half a cup of chopped tomatoes. She only has 1/8 of a cup, measuring cup. How many times should Tamara fill this measuring cup for the tomatoes? So if you think of it, you have here's a cup, and this, we'll say this is the half a cup. Okay, but then you have a 1/8 cup. This is all she has, is this 1/8. She doesn't have the half, but we're wanting to figure out how many 1/8 do I need for that. So once again, you're thinking of, okay, I am breaking this half into sections. So it's a division problem. So I could say I have a half of a cup divided by 1/8, because that's how many, 1/8. Let's change that. I didn't mean to put a half. There we go. Okay, so let's think about this. Once again, we're dividing, so we want to change this to a multiplication problem. So I have a half times 8/1, because remember, we take the reciprocal of the divisor. Then we can multiply straight across. 1 times 8 is 8. 2 times 1 is 2. Then 8 divided by 2 would give me 4. So I would have to do 4 1/8 cups to make an actual half of a half cup. And the way you could think about this too is think about doing 1/8 plus 1/8 plus 1/8 plus 1/8, because that would be multiplying it by 4. And if you have 1/8 plus 1/8 plus 1/8 plus 1/8, that would give you 4/8, which is half a cup. So we can check our answer to make sure it makes sense. Okay, we are on to question B. So let's look at this question. Six Flags Amusement Park has found that 3/5 of its customers ride the Colossus roller coaster. Of these, 1/4 will ride it again. What fraction of the customers will ride the roller coaster twice? So my first thing I'm thinking is it dividing something up into separate sections? Or is it looking at a part of what we have? This one is looking at a part of what we have. We have no 3/5 rides, but then they want to know, then they said only 1/4 will ride it again. You could think of this similar to our cheese questions or pizza questions we were talking about. If you have half of a pizza and then you only eat 1/4 of it, how much pizza did you eat? So if you think about this, I'm actually going to use a model to start us. So if these represent all the customers, only 3/5 of them will ride it to begin with. So only that section. But of that 3/5, only a 1/4, so if I'm thinking about fourths, only 1/4 of them will ride it a second time. So these 3 would be the only ones. 3 out of all of the whole amount, 20, would write it a second time. So this is like a multiplication problem, because we are thinking 3/5, and only of that 3/5, only 1/4 will write it again. So you just multiply straight across, and we get 3/20. Sometimes the model is easier for us to think about versus actually doing a multiplication problem such as this one. Question C. A piece of plywood 24 inches wide is cut into 2.5 inches wide. How many strips can be cut of this width? So I'm thinking they're cutting these into sections. So I am sectioning off. So sectioning off would mean I'm actually dividing it up. So I know I have 24 inches. I'm going to divide this into 2.5 sections. But remember, we are going to change this to a multiplication problem since we have a mixed number. So I'm going to write 24/1 times, I have to think, what is 2.5 as a improper? Well, 2 times 1 is 4, plus this one makes 5. So 2.5 is the same thing as 5/2. So I'm going to write the reciprocal of 5/2, which would be 2/5. And then I can multiply straight across. 24 times 2 would give me 48. 1 times 5 would give me 5. So then I think, how many times will 5 go into 48? It'll go in there 9 times, because 9 times 5 is 45. And then 48 minus the 45 would be 3/5. So they could only actually make 9 total strips, and they would have 3/5 left over. Okay, we are now on question D. Miss Smith has bought 3.5 yards of yellow fabric. She used 2/3 of that fabric to make a chicken costume. How much fabric did she use? So this problem is not talking about cutting it up and saying this section gets this much, this section gets this much. That's when we're thinking about division. This one's actually saying that you're getting 2/3 of something, which is a multiplication problem. So it's really saying she had 3.5 yards and she used 2/3 of that. Okay, because I'm not trying to figure out how many 2/3 are in 3.5. I want to know what is 2/3 of 3.5. So remember, when we have a mixed number, we need to change it to an improper. So 3 times 2 is 6, plus the 1 is 7, halves times 2/3. So 7 times 2 would give me 14. 2 times 3 would give me 6. Then I have to think, this is the same thing as thinking 14 divided by 6. 6 will go in there twice, which makes 12, and I would have 2 6 left over, or 2 1/3 of fabric left over. Or fabric used, sorry, not left over. How much fabric was used? Because 2 1/3 would be 2/3 of 3.5. I know this was a long video, but we just wanted to go over the review to make sure that you understood all of the questions on the review. Just study the review, look over your notes the night before, and you will do great on the test. If you have any questions, please come into tutorials or ask us during class this week.